Hey guys, welcome back to the DAHKTUBE. And before we get started, don't forget to like, share, comment, and subscribe. Now we'll be doing three things today: multiplying and dividing surds, perfect squares of surds, and conjugate surds. So the first rule of multiplying and dividing surds is that once the orders are the same, you can multiply them under one big square root. The same thing for if you're dividing. If the orders are the same, you can divide them under one big square root. So for example, let's say we have root 7 times root 3. So now because the orders are the same here, we can just say big square root, 7 times 3. And 7 times 3, that's 21. So we have root 21. And that would be the answer. Next example, let's say we have 4th root 5 times 4th root 9. So because the orders are the same, we can have one big square root of 5 times 9. So it's 4th root of 45. So that's basically all there is to multiplying surds. So let's say we have root 35 divided by root 7. So now they have the same order, so we can simply put them under one big square root. So that's 35 over 7. And we know that 35 divided by 7, that's 5. So the answer would be root 5. Next example, let's say we have 5th root of 72 divided by 5th root of 6. So again, the orders are the same. They're both 5. So one big square root, and that's 72 over 6. And we know that the answer would be the 5th root of 12. So now we're going to be doing what is called a perfect square of surds. So we simplify by expanding the brackets. So a perfect square is when you have, for example, 8 plus root 3. So it's a perfect square when you have a term plus another term all squared. So the first thing you want to do is, this means you're multiplying what is inside a bracket by itself. So it would be 8 plus root 3 times 8 plus root 3. So now we'll be multiplying this by this, so distributing this by this by this, and this by this. So 8 times 8, so let me do it in parts. So 8 times 8, that would be 8 squared. And then you'd have 8 times root 3, so that would be plus 8 root 3. Then it would be root 3 times 8, which is the same thing as 8 root 3. And then you'd have root 3 times root 3. Now, in the corner here, I'm going to do what root 3 times root 3 would be. So that would be saying 3 to the half times 3 to the half. When you're multiplying and you have the same bases, you add the powers. So it would be 3 to the half plus a half. And we know that half plus a half, that's 1. So it'd be 3 to the 1, which is equal to 3. Or another way to think about it is, it would be saying root 3 times root 3. So that would be root 3 squared. So that means you'd have 3 to the half raised to the power of 2. That would be 3 to the half times 2. So the 2's would cancel. You'd have 3 to the 1, which is the same thing as 3. So it would be plus root 3 squared. So 8 squared, that would be 64. And because these have the same orders, we can add the coefficients. So it will be 8 plus 8, which is 16, root 3. And we just worked this out, and we said that once you're squaring a square root term, it will give you the term itself. So that's plus 3. Then you group your like terms, which will be the 64 and the 3. That will give you 67. So it will be 67 plus 16 root 3. And that would be the final answer. So let's try a perfect square when the symbol here is negative. So let's say we have 5 minus root 2 all squared. So again, we would write 5 minus root 2 in one bracket, and it is being multiplied by itself here. So it will be 5 times 5, so that's 5 squared. And then it's 5 times that, so that's minus 5 root 2. Then it will be 5 times that, again, minus 5 root 2. And then you have negative times a negative, which is a positive. There will be positive root 2 all squared. So you'd have 25. So because the orders are the same here, we can add the coefficients. So it will be minus 10 root 2 plus 2. Remember, this is 2. So the answer will be 27 minus 10 root 2. So that's basically what you mean by perfect square. You can, so when you have two items inside and a squared term here. So it doesn't matter if it has a minus here or a plus. So now we're going to be doing what you call conjugate surds. Now a conjugate meaning, for example, if you have A plus root B, then the conjugate would be A minus root B and vice versa. So the symbol changes. So for example, let's say we have 5 plus root 2 being multiplied by its conjugate. The conjugate would be 5 minus root 2. And it would be the same distributing. So 5 times 5, that would be 5 squared. And then 5 times minus root 2, that's minus 5 root 2. Then you have positive root 2 times 5, that's plus 5 root 2. And then you have plus root 2 times minus root 2, that gives you minus root 2 squared. So the thing with conjugate is that the inner terms here would cancel each other. So now you'd have 25 minus, this would give you 2. So the answer would be 23. Another example, let's say we have 4 plus root 3 multiplied by its conjugate. The conjugate would be 4 minus root 3. So it would be 4 squared minus 4 root 3 plus 4 root 3 minus root 3 squared. That would be 16. The inner terms would cancel. Minus 3, so the answer would be 13. So that's it for today. Thank you guys for staying tuned. Don't forget to subscribe, and I'll see you guys next time on the DAHKTUBE.